Welcome to tonight's video on graphing the tangent and cotangent. Before we get started with that, let's just review quickly the exact values for the trig functions on the unit circle. When we talk about theta equaling 0, the sine of 0, remember, is 0. The cosine of 0 is 1. Remember, cosine is equal to x, sine is equal to y, tangent is equal to y over x, which otherwise means sine over cosine. Well, if I take sine over cosine, 0 over 1 is 0. The cotangent, remember, is the reciprocal. So 1 over 0 is undefined. At pi over 4, it's root 2 over 2 and root 2 over 2. When you divide the same things, you get 1 for each of them. At pi over 2, the sine is 1, the cosine is 0. So 1 over 0 gives you undefined, but 0 over 1 gives you 0. 3 pi over 4, the sine is root 2 over 2. The cosine is negative root 2 over 2 because it's in the second quadrant. The tangent would be negative 1, and the cotangent would also be negative 1. At pi, the sine is 0, the cosine is negative 1, the tangent is 0, and the cotangent is undefined. Because remember, cotangent is x over y, or cosine over sine. For 5 pi over 4, they are both negative, because that's in the third quadrant. And negative over negative gives you positive for cotangent and tangent. 3 pi over 2, the sine is negative 1, the cosine is 0. The tangent is sine over cosine, which is undefined. The cotangent is 0. At 7 pi over 4, which is in the fourth quadrant, the sine is negative. The cosine is positive. The tangent is negative, and so is the cotangent. And back at 2 pi is the same as 0. So those give you some values. We didn't do pi over 3 and pi over 6, but we don't need those to graph the cotangent and tangent. So those are the values on the unit circle that will help us graph tangent and cotangent. All right, and this is just to review right here how you found those values and how we did it using the 45, 45, 90, and the quadrantal angles. Now, by using the chart here that I made, notice the tangent of 0 is 0. The tangent of pi over 4 is 1. There's a vertical asymptote at pi over 2 because it's undefined. The tangent of 3 pi over 4 is negative 1. Tangent of pi is 0. 5 pi over 4 is 1. 3 pi over 2 is undefined. Then 7 pi over 4 is negative 1. And 2 pi is back to 0. And if I kept going, you basically would have another graph that looks like this. And if I kept going this way, at negative pi over 4 and then negative pi over 2, I would have a graph that looks like this. So notice it just looks like kind of like a snake. Now, if I flip the page, and this tells me how I expanded it to the left and right, negative pi over 4, negative pi over 2, and I expand it this way, and if I expand it that way, putting the asymptote here, all right, notice it repeats itself about 3 times. All right, but remember, we're only graphing one period, and if you notice here, each period is equal to, well, if I go from negative pi over 2 to pi over 2, that's one period, and then notice it repeats itself from pi over 2 to 3 pi over 2, and then from 3 pi over 2 to out here, which would be approximately, this is 9 pi over 4, so this would be 3, actually, sorry, it would be 5 pi over 2, because it'd be 10 over 4. To 5 pi over 2. So notice the period, each period is worth pi, because negative pi over 2 to positive pi over 2 is pi. 3 pi over 2 to 3 pi over 2, that's pi. And 3 pi over 2 to 5 pi over 2 is pi in length. So unlike the sine, cosine, cosecant, and secant, where each period is 2 pi, the tangent period is equal to pi. When we graph one period, we're going to choose the period that includes 0. So to graph one period of tangent, we're actually going to graph between negative pi over 2 and positive pi over 2. That is going to give us one period of the tangent function. So basically, one graph would look like this period here. That is what we're going to use as our graph for the tangent. And so the domain is from negative pi over 2 to positive pi over 2 for the tangent function when we graph it. Using those coordinates in the beginning, if we look at the cotangent, it looks like this. So notice there's about 2 periods in here. It repeats itself 2 times. And so in order to graph one period, we're just going to graph between 0 and pi right here. That's what we're going to use. So the period of the cotangent function as well as the tangent is equal to pi. Because after pi, notice it repeats itself. So looking at the base tangent function, y equals tangent x. If I were to graph it, my domain, remember, is from negative pi over 2 to positive pi over 2. Remember, there's asymptotes at negative pi over 2 and at positive pi over 2. There's always asymptotes at the end. The tangent of 0 is 0. The tangent of pi over 4 is 1. The tangent of negative pi over 4 is negative 1. And so notice it goes down this way and then up that way. If we look at the tangent function. So it's a snake. Notice it's increasing because if you go from left to right, it's going up. If there is one reflection in it, meaning if you had either a reflection across the x or a reflection across the y, then it would decrease. All right, because that reflection would flip the graph. If there's 2 reflections, if there's both the x and y, then it cancels itself out and it goes back to being an increasing function. That's what it's talking about there. Remember, the period is equal to pi. The phase shift, pi times the horizontal stretch or shrink. The phase shift is equal to the horizontal shift. And just like cosecant and secant, there is no amplitude. For cotangent, when you graph it, it's going to be between 0 and pi. And once again, there's going to be asymptotes at the beginning and at the end. The cotangent of pi over 2 is 0. The cotangent of pi over 4 is 1. The cotangent of 3 pi over 4 is negative 1. And notice the cotangent function is decreasing from left to right. So with no reflections, the cotangent decreases. With one reflection, it's going to increase, and with two reflections, they would cancel each other out and decrease. All right, ignore this for right now, because we already talked about how to find the period, because remember, period of cotangent is equal to pi times the horizontal stretch or shrink, just like tangent. The phase shift is equal to the horizontal shift. And once again, there's no amplitude with cotangent. Now, for tangent and cotangent, these are the three main points that you need. So for tangent, you have the two vertical asymptotes at negative pi over 2 and pi over 2, and you have 0, 0. For the cotangent, you have the two vertical asymptotes at 0 and pi, and you have pi over 2 and 0 as your main point. All right, I hope you enjoyed the video, and in class we'll do some examples using those main points with reflections. Have a good evening.